Welcome to doassignment-ca. We want to solve question 19 in chapter 5. The man has a weight W and stands at the center of the plank. If the planes at A and B are smooth, determine the tension in the cord in terms of W and theta. To do that, we'll use some equations of equilibrium and some trigonometry. Let's start with the equation of moments about point B, which tells us that the sum of the moments of all the forces acting on the beam around point B must be zero, since the beam is not rotating. We can write this equation as follows: the moment of the weight W about point B, which is the force W multiplied by the perpendicular distance from B to the line of action of W, minus the moment of the reaction force at A about point B, which is the force NA multiplied by the perpendicular distance from B to the line of action of NA, must be zero. Since the angle between the weight and the beam is phi, we can use trigonometry to express the distances in terms of L and phi. Thus, we obtain the equation W times L over 2 cosine phi minus NA times L cosine phi equals 0. So from here NA would be equal to W over 2. Next, we apply the equations of equilibrium in the x and y directions, which tell us that the sum of the forces in each direction must be 0. In the x direction, we have the x component of tension T in one rope acting to the right, and the x component of reaction force NB at B acting to the left. We can project these forces into their x and y components using trigonometry, and obtain T times cosine theta minus NB times sine theta equals 0. In the y direction, we have the y component of tension T in one rope acting upwards, the y component of reaction force NB at B acting upwards, the weight W acting downwards, and the reaction force NA equal to W over 2 that is upward. Again, using trigonometry, we can write T sine theta plus NB cosine theta plus W over 2 minus W equals 0. Now we have two equations and two unknowns, T and NB. We can solve for T and NB by solving equation 1 and 2 simultaneously. After some algebraic manipulation, we obtain T equals W over 2 sine theta. NB equals W over 2 cosine theta. These are the solutions we were looking for. The tension in one rope is proportional to the sine of the angle between the rope and the beam, and the reaction force at B is proportional to the cosine of that angle. These results make sense, because as the angle increases, the tension in the rope decreases and the reaction force at B increases, since the weight is being supported more vertically. I hope this video has been helpful in understanding how to solve a system of equations in mechanics using equilibrium and trigonometry. Thank you for watching. Please like, subscribe, and share this content with your friends.